Okay, so now we look at the examples under speed time graph. So we are told that the diagram below is a speed time graph of a journey. So we have the diagram there. I'm sure we are seeing it. We have under x-axis, we have 0, 10, 20, and 40. Then for time, we have 0 and 20 seconds. We have 20 seconds there. So this is what we have. So then the questions now. Questions are, question number 1 says, rather all the questions are about calculate A, the acceleration for the first 10 seconds, B, the deceleration for the first 20 seconds, then C, calculate the distance covered in the first 10 seconds, then D, the total distance in 40 seconds, then E, the average speed for the whole journey, then we also have the distance or the speed, not the distance but the speed at 25 seconds. Now, my advice, before you work out this question, please pause this video now and copy this question. You pause it now and copy these questions. So I want to believe you have paused. Please pause and copy these questions. Thank you. I believe that now you paused and the questions have been copied. Now we see how these questions can be answered. The first question is saying, calculate the acceleration for the first 10 seconds. From what we have learned, we have been told that acceleration, it is the change in speed. So what was the change in speed? So when we mean by change in speed, in other books they say this is the same as saying second velocity or final velocity minus the initial velocity or the first velocity over the final time taken minus also the initial time. Now what is our V2? Our V2, it is the velocity 2. Mind you, the velocity is the same as speed, meaning the speed, the y-axis is for speeds. This is 0, this is 20. So our V2 is 20. Then our V1 is 0 because it started from 0. Then we have our T2 is equal to, what is our T2? In the first 10 seconds, it will be 10. Then our T1, which is the initial time, it will be 0. Then we are going to say our acceleration is equal to 20 minus 0 over time taken, which is 10 minus 0. So we are going to have our acceleration is equal to 20 over 10. And our answer, mind you, the 20 you are seeing here, it is meters per second. Then this one is just per second. Meaning even these, the units, they are dividing themselves. So when you are dividing M, this slash means over, which will be over S, then divided by S, this S here. Meaning I'll just put a placeholder, which is 1. So this will be M over S multiplied by 1 over S. Meaning we are going to have M over S squared, because S multiplied by S is S squared. So this is where it comes by saying acceleration has got the units meters per second squared. So we are going to put these units there. So we are going to say our acceleration is equal to 20 divided by 10. The answer is 2. So we are going to have 2 meters per second squared. So this is what we have under the first question. Please copy this one. Also, can you pause the video because I'm about to lab this, so that I go to question number B. Question number B is saying we calculate the deceleration for the first 20. The deceleration for the first 20. So instead of the first 20, it's supposed to be written as the last 20 seconds. So deceleration meaning from here up to here, the last 20 seconds. So deceleration, we said it is negative acceleration, meaning we say final velocity minus initial velocity over time taken. So we are going to have is equal to what is our final velocity from here up to here. It is the same as from here up to here. So our final is 0. 0 minus, where is it coming from? It is coming from here, which is our 20. What is the time taken? The time taken is from here up to here, which is from here up to here. So this one, it will be 20, because 40 minus 20, the answer is 20. So we are going to have deceleration, which is negative acceleration. We still use the same symbol for acceleration. The answer will be 0 minus 20 to be negative 20 over 20. Negative 20 over 20. So we are going to have, if you want, you can say deceleration, then it will be negative 20 divided by 20. The answer will be negative 1. Negative 1 what? Meters per second squared. Why? Because the speed there, which is deceleration, is meters per second. Then the time taken is also in seconds. So we are going to have negative 1 meters per second squared. Please, can you also pause this one and copy, because I'm labbing it. Thank you so much. Now we go to question number C. So question number C says the distance covered in the first 10 seconds. Remember we said the distance under velocity time graph or under speed time graph, it is found by finding the area of that shape. So when you look at this shape here, the first 10 seconds from 0 up to 10, this is the shape we have. This is the shape we have. Now, what kind of a shape is that? So the kind of the shape which has been formed there is known as a triangle. So the area of the triangle has got the formula 1 over 2 BH, where our B is from 0 up to 10, which is 10. Our H is the height from 0 up to here, where this line ends. So it is 20. So we are going to have our area is equal to 1 over 2 multiplied by 10 multiplied by 20. So I'm going to say 1 multiplied by 10 multiplied by 20, we have the answer 200. So 200 over 2. And our final answer will be 100. So meaning we have 100 meters over question number C. The distance covered in the first 10 seconds is 100 meters. Now we go to the distance. The other question, which is question number D, which says calculate the total distance in 40 seconds. So the total distance can be covered by finding the area of this, the first shape. Then we go also to the area of this one, this other shape here. I don't know what shape is this, but according to mathematics, this shape is known as the rectangle. Then finally, we go to the area for this shape, the final shape we have here. So that is what we are going to do to find the total distance in 40 seconds. Or we use the formula for trapezium. So I will encourage you to to use either formula. But as of now, I'm using the formula for trapezium. So question number D, we are going to say area is equal to 1 over 2 A plus B, then we write H. What is our A in this case? Our A is from here up to here, which is 10. Our B, it is from 0 up to here, which is 40. And our height is 20, because from here up to here, or from here up to there, is 20. So we are going to say our area is 1 over 2 multiplied by 10 plus 40, then multiplied by 20. So we are going to have area is equal to 1 over 2 multiplied by 50 multiplied by 20. So we are going to have area is equal to this one into this, it goes 10. So 50 multiplied by 10, we have 500. So this is the total distance we have for 40 seconds. Now, there are other questions which may come by asking you to find the average speed. So average speed, which is question number E, it is average speed is equal to total distance. So the total distance covered over total time taken. Now, what is our total distance covered for the whole journey? It is what we have just from finding under D, which will be 500 meters. Then what is the total time taken? It is 40 seconds. Now, what is 500 divided by 40? So, 500 divided by 40, we are going to have 12. Okay, 12.5 meters per second. So this one will be our average speed. So I again encourage you to pause this video and you finish copying, then you go to the next question, which is question number F. Now we have the last question, which says calculate the speed at 25 seconds. So we have, this is our shape, where we have this. This is our 40. We have our 20 there. We have our 10. This one is our 20 also meters per second. These are seconds. Now the question is calculate the speed. The speed at 25 seconds. I've written it as 25 seconds there. What are we going to do? So, the formula you use to find the speed of such kind, you use the same formula you use to find the acceleration. Acceleration used to find the acceleration. Acceleration is equal to final velocity minus initial velocity over time taken. Now, we are finding the speed at this point here, where it is 25 seconds according to me. So meaning we are finding the speed. The speed is always to y-axis. So what do we do? What do we do? We are going to use the same formula, but now we are finding this, which is the velocity, which is the speed. So now meaning we're going to make this one subject of the formula by crossing multiply. This one times this one, we are going to have 80. Then this other side, it will come this side. It will be plus u is equal to v. Or it can be written as v is equal to 80 plus u. Now, our A is the deceleration we found when we were finding the deceleration. What question? Question number B. Our answer was -1 meters per second squared. What is our t? Our time taken now, it is from 20 here up 25, which is 5 seconds. What is our u? Our u, it is the initial velocity there, which is 20 meters per second. So we are going to say our v is equal to at plus u. Our v is equal to, our a is -1, our t is 5, so to be 5, then plus our initial velocity, which is 20. So we are going to have our v is -5 plus 20. Now -5 plus 20 is 15. So meaning we're going to have 15 meters per second. You can use v, or you say the speed s, which stands for speed, which will be 15 meters per second. So this is our answer for that question. Otherwise, we end here. In our next video, we are going to look at sample exam questions which comes under velocity time graph or speed time graphs. And these sample exam questions are always in paper 1, which is always the last question under paper 1, which is question number 23. Or if they increase questions, it can be question number, other number. But what we know is that it is always the last question. Otherwise, thank you so much. We end here. And let's meet in the next video. We are going to look at sample exam questions. Thank you.